Awesome. So my name is Varun. Badhwar. I came in through the acquisition of Redlock. Spent about 13 years in cloud security space. I'm curious, how many of you here are also responsible, along with what I call your day jobs of securing your core infrastructure, to also think about security for applications that are moving to the cloud? Yeah. Quite a few of you. I saw some of your bios. I think there's some of you here with AWS certifications and things. So exciting conversation here, hopefully. Look, Palo Alto Networks has a pretty broad portfolio of security. The way we think about security for cloud, we think about three main areas. We think about security for SaaS applications. We think about security for public cloud. And we think about security for your access as your data and your users are moving and accessing these cloud applications. For the sake of time today, we've decided to focus on really, I think, a top-of-mind subject, hopefully for many of you, which is as you start taking your applications and either lifting and shifting them into public cloud, platforms like AWS, Azure, and GCP, or rewriting cloud-native applications. So what is the impact from a security standpoint? What is the opportunity for us to think about security differently in these environments? And hopefully we can have an engaging conversation around that. Just to sort of start this off, as we've been thinking about security for public cloud, a few things change. First of all, cloud adoption is more developer-led than CIO-led. Like CIO strategy may say digital first, but ultimately it feels like a lot of the developers are going and deciding which cloud platforms make the most sense for which cloud environments, and they'll ultimately govern these environments. DevOps is the one that's really deploying applications. They have administrative privileges. They have root access into these accounts. And security, all of a sudden, where we used to come in and have a gating process to approve every firewall change and approve pretty much any operating system deployed in there, all of a sudden we're going in and saying, wait a minute, we need to have visibility. As a show of hands, maybe I'll ask a question. How many of you here, if you wanted to know sitting here today, do you have databases running in public cloud? And if you have, where are they running? Do any of us have systems to be able to? Okay, excellent. How would you do that? I'm curious.
We have a bunch of systems that track all that.
All the assets?
All the assets and where everything is. We just don't put anything in the cloud without doing that. So it's not developer-led, actually. It's security-led.
So good. I think that's I think that's unique and probably advantageous to the way your organization is approaching it. I would imagine there's some other organizations here where developers have gone out there and all of a sudden you're being told, hey, you know what? You got to go look into AWS.
I'm laughing at that comment because exactly what I'm thinking is we have developers and I find stuff that they do and I just want to walk over and just smack them upside the head for some of the stuff they do.
Yeah.
Yes.
And unfortunately,
that happens, unfortunately.
And unfortunately, that happens. And it's interesting. Gartner stats show that 99% of cloud security failures for the next 5 years will be the customer's fault, as they call it, which is your developers are trying to do the right thing, but ultimately they just don't have the tooling, the understanding, the awareness on how to go about deploying these. So they're moving fast because that's what they're being told to do. But for us as security practitioners, we now need to retool completely to know what do you have in the cloud. You are very unique, sir, to have an asset inventory system. Most organizations, 99% of them, actually don't even have an asset inventory system for what's deployed in the cloud. Okay, once you understand what's deployed in the cloud, then the question is the changes that are being made, who's making them? Why are they being made? Some of the best organizations in the world, some of the biggest transportation companies, biggest electric car companies have had compromises because of simple things. Developer left keys on GitHub with their code checked in. How do you know? What do you do, right? Or what kind of data is stored in all these S3 buckets that people are putting terabytes and petabytes of information up in? Right? It's hard to tell. And so, we believe we need to think about security a little bit differently in public cloud. Whereas traditionally we've thought about security a lot in runtime, right? So a lot of times we'll hear customers say, oh, I'm not even in production in the cloud. And then we get calls saying, I just got crypto mined, $400,000 bill in 1 week. So, we think security done right for the cloud isn't just security in runtime, isn't just security where you're validating their code once it's built, but it's how do you shift that left to have a desired outcome where you want to allow your developers to feel accountable, feel ownership of their environments, yet for you to get the visibility you need, get the governance and guardrails you need to establish those guardrails in a way that developers understand them. So if we agree at a high level that our a typical life cycle in deployments for the cloud are build, deploy, run, and it's constant, right? You're building, deploying, and running. You can't wait to have the gate at runtime. Once the code is written, it's deployed. Guess what? A lot of this is happening using infrastructure as code. Nobody is even going in and attempting to manually make changes in these environments. They're using Terraform, they're using CloudFormation. And one problem in the source that's templatized and automated now goes triggers in 50 different places when these builds are triggered, right? So we wonder then, can we put security into the build phase? Developers are using Jenkins. Can we put the checks and give them the best practices checks in a way that they understand how to consume them? Just like when they hit a sort of red-green deployment, the checks where their QA and automation is happening, can we do security checks right there? Can we check for vulnerabilities in containers right there before they even build an image? So we think that's really important. We think then in deployment time, you need to sort of continue and have another gating process and ultimately take it all the way through runtime. And by no means will you be able to check for everything in build phase, but we do think if you can, the way I like to think about it is an 80-10-10 rule. Can we catch 80% of the things at the build phase and really put the onus on the developers to fix these? Because guess what? You have way more developers in your organization than you have SOC analysts to respond to alerts. So if we went the old-fashioned way, if we can call it that for a moment, we generated lots of alerts for violations of policy, violations of sort of your architectural requirements, and those were Splunk alerts or those were some other alerts in the SOC. What do you do with them? Your analysts aren't really familiar with these platforms in the cloud. If they're being told that, hey, this KMS hasn't been rotated in over 90 days, well, heck, what do? I don't have control. I don't have an admin permission into that environment. And so if 80% of the feedback can be delivered right to the developer, because they all have good intentions, they want to fix these problems. And then 10% of the things really go into the SOC for investigations. So these are things like potential security compromise on a stolen credential or an access key in AWS, or potentially seeing suspicious traffic to crypto miners. Those probably warrant more investigations. And also then leverage automation for the last 10% of the cases, because let's say you have an open S3 bucket or an open security group in AWS with port 22 open to the internet, and you're just not allowing that in your environment. Just shut it down. Use automation, right? And you'll hear about Demisto and some of the other things we're doing in automation. But at least from a philosophy standpoint in cloud, we believe, and that's the right way to think about this. That's the scalable way to think about this. So if we agree about that for a moment, that you need security in build, deploy, and run, there's yet another dimension where you need holistic security. None of your cloud applications are going to be 100% VMs or 100% PaaS. They're like of server VMs. And so the question is, do you go start buying best of breed products for each one of these, and now you end up with 60, 70 tools like you did in the on-premise data center? Or do you have an opportunity actually to have consolidated visibility such that if an application starts at a VM, talks to an S3 bucket, that then triggers some notification service, you have visibility into that entire application lifecycle. And that visibility is consistent. That control for policy and governance is consistent. And all the threat detection and incident response around the stack is consistent. So, you may have heard recently we announced our acquisition of Twistlock and PureSec. Just wanted to sort of give you a sense of where that fits in, is because we want to believe, and we hope you believe, that while you want best of breed security for containers, best of breed for PaaS services, best of breed for infrastructure as a service, you do want them integrated. And that's sort of where our Prisma public cloud offering really comes to be. Now, architecturally, the way we deliver these solutions, and I'll pause and take some questions, is we want to do this in a most DevOps friendly way that we possibly can. So our Prisma public cloud offering actually does not intrude into your environments, is not a proxy, is not an inline solution. Rather, it works off of cloud native APIs. And we talk about this as an embrace and extend model. We take all the data that the cloud providers collect through the APIs, getting read-only access into your environments, and within minutes, we're correlating this data across the popular cloud providers. And the first thing we do is try to optimize it for consistency. Right? The APIs of Azure are very different than the APIs of AWS, than APIs of GCP. So we basically take 4 distinct data sets. We take flow logs from the cloud providers that give us all north, south, east, west visibility of who's talking to what without being in line. We take all the user activity information. so understanding of what your developers are doing in these environments. We also capture information about configurations of resources. So how many S3 buckets have you got? How many EC2 instances? How many IAM profiles? What changes are being made into those things? And then we'll augment that data with third-party feeds, whether they're threat intel feeds or vulnerability feeds of Qualys and Tenable. We'll capture all of that information together. And then look, we use a logical way of, first of all, applying best practice policies, rule sets, wherever we can. So out of the box, we ship with about 400 policies, and every week we add more. So if you're thinking, what are these policies? Cloud providers ship about 1,400 features a year. You, as security practitioners sitting here, are wondering, what could my developer do wrong next? What do I need to look out for? These are policies. These are rules. And these best practices are mapped to compliance standards like ISO, SOC 2. It was a fascinating conversation earlier with Nir and Edward yourselves and a few others on controls and consistency and what standardization do we use? How can you prove you're secure? Well, a lot of the standards, as you mentioned here earlier, were never written for the cloud. So you, the customer, want to align with the NIST 800-53 framework. Somebody's got to do the hard work, taking that standard and making them technical controls for each cloud provider. Well, we do that for you out of the box, right? So that's all of the sort of policy-based. Then there are things we simply can't catch using policies. Stolen credentials, cryptojacking use cases, suspicious traffic, port scan sweep attempts. So that's where we'll use machine learning based on this data lake that we've sort of created across your cloud platforms. And we'll use machine learning to sort of infer and detect and report on those anomalies. The end result of this, if you think about it at the very top, is a few different things. First of all, for those of you not as fortunate as you, build you the CMDB, build you the asset inventory system out of the box, knowing what assets are there, where they're deployed, what changes are being made, and who's making those changes, all part of that. We then give you all the best practice guardrails for your developers aligned to the various compliance standards, so you have that there. We then give you more of the threat hunting, detection, and response. So I asked you the question, where could you go and ask how many databases are out there in your public cloud environment? Take it a step further. How many of them are connected to the internet right now? You don't have a way to ask that question. So this system gives you that ability.
The developers did it, they're all connected.
Yes. On that note, I'll actually pose a question to you. Any guesses on what percentage of customers have internet-connected databases? Do you think across a research that if you wondered you do?
More than they think they do?
80%. 96.
I'd say 100.
Yeah, so an interesting statistic, 92% of firewall rules, aka cloud-native firewall rules like security groups, have unfettered outbound access. There's just no control. It's kind of scary. If I told you that we have seen a third of databases in the cloud to be internet connected, that surprise you?
I thought the number would be higher.
But a third of the databases, now, almost every customer has that.
But I was thinking it was 90% were internet connected, not a third.
But just scary stuff, right? Think about this. We've spent the last couple of decades as a security industry solving these problems. How are they emerging in the cloud? It just warrants different architectures, different approach to security. And that's sort of what we're trying to build here, right? So continuing on, you have threat detection, you have this ability to ask questions arbitrarily, investigate incidents. It becomes kind of a DVR for your cloud. And the best of it all is sort of we believe in an open ecosystem. As part of your SOC, at the end of the day, you're going to have this in conjunction with tools like vulnerability scanning tools, identity tools, threat intel tools. And we try to sort of integrate those in a way where not only can you have workflows that are very developer friendly, like Jira and ServiceNow, PagerDuty, Slack, but also very SOC friendly. Because in this sort of DevSecOps era, we're not going to be successful if we over-rotate on one or the other. We have to have consistency in integrations and workflows across both.
What's your experience with people mapping their existing on-site policies to the cloud? That tends to, in my mind, be problematic because there are very different constructs for infrastructure.
Yes. What I've found is for customers that are just starting out, the basic people want to start with is CIS. It feels like CIS checks. The Center for Information Security has actually created a good, very cloud-specific benchmark. They're one of the only ones where there's a standard that's built for AWS, for GCP, for Kubernetes, for Azure. And so it feels like if organizations don't quite know where to start, and to your point of taking legacy standards and trying to move them to the cloud,
I'm not talking about the standards and baselines and benchmarks, because those will just happen naturally.
yeah.
I'm talking about their existing policies, because a baseline and benchmark to me is not really the policy.
So
policy-
policy being, so not technical controls, you're talking about policy being thou
Regulate.
shall not, data shall be encrypted at rest. Is that
Correct.
policy?
That's policy.
Okay. Yes, I think a lot of them have policies. Most organizations we work with also have drafted and spent years drafting a cloud security and architecture blueprint.
Correct.
The hard part is how do you validate the technical controls?
That's all. I was just wondering what you guys have seen from a mapping of one to the other, because there's big holes.
There are big holes. And so that's where most of our customers use technologies like this, because not only does it have over a dozen industry controls and standards, so ISO, NIST, SOC 2, PCI, HIPAA, GDPR just out of the box, but also gives customers the ability to take their policies and map them to a custom control framework just through the UI or through our APIs. So that combination is usually what we've seen.
And do you automatically, so if I loaded up a policy, whatever, can you spot the things that are just impossible to implement inside a cloud?
So again, it comes down to there are some things that are very technical controls. There are some that are procedural controls. Obviously, all the technical controls that through the API can be validated, we validate. So for example, with the CIS benchmark, about 76% of the controls are technically can be automated. So we've automated those. But there are still 24% that just can't be automated. These are more of people policies, training policies, and so.
Give you that.
Yeah.
Yeah.
I'm
So
concerned
earlier you
about,
said,
when you talk about encryption, I'm really concerned about key management.
Yeah.
Because who manages the keys is generally the cloud, not
Yes.
the end user.
Yes.
That's a big problem for certain industries.
Yes. But if you wanted us to have controls that validate that keys are being rotated in the cloud, you're using the KMS correctly, those are technical controls that you can
Correct.
apply here. Sorry, I know you had a question.
yeah, earlier you said that you tie into the vendor's APIs.
Yes.
I'm wondering if you go another level than that. For instance, in AWS, are you just pulling the same stuff out of CloudWatch, or are you getting your data directly?
So combination. So we'll pull CloudTrail, we'll pull VPC flow logs, but then we'll also make describe calls to every resource in the cloud, because we want to capture every diff of every change made. Meaning, if while you were here, your developer this morning came in, modified an existing security group from allowing access only on port 443 and extended that rule to allow port 80, we want to track that change, and such that you have auditability and forensics tracking on all of that. And so for that, we use a combination, right? CloudWatch will tell us something changed. Then we'll make a describe call, see what changed, and we combine this. Or to give you another example, this is why cloud security is different. If you just looked at NetFlow logs, if anybody here looked at VPC flow logs, they're painful. They are absolutely painful. They don't tell you directionality of traffic. They don't tell you what's behind an ENI, an Elastic Network Interface. At 9 a.m., it could be in a database talking to a web server, which is just, maybe it's web server rather talking to a database. If that role switched because somebody reassigned the IP, you wouldn't know. Or two VPCs, you could have the same IP address. So when you start aggregating this data, it's extremely painful. So a big part of what we do is take VPC flow logs, and then we'll match the ENI to say, right now, at this second, which instance is it applied to? Then we'll use machine learning to start to infer, based on the traffic we're seeing and other components, what is that instance? What do we think that is?
How was that presented?
So, great question. Thank you. Let me give you a couple examples of how that data is presented. So here's an example of just a pure asset inventory screen. Hopefully you guys can see it back there. This is basically telling you how many resources will be found across multiple clouds, which service, how many EC2 instances, how many S3, how many Azure virtual networks, how many of them against our best practices that we ship out of the box are passing, how many are failing. All of that information is presented in this screen as an example. Let me see, we have a couple of other screens I'll show you. This, on the other hand, is where we're presenting to you anomalous user activity. So this is a bit of a heat map of your developer that's showing you on the access here the different services and APIs in the cloud the developer is using alongside a time. And the big bubbles that are colorful in red are usually high severity findings around these, meaning the developer here is logging in from a location we haven't seen them log in from before, performing activities we haven't seen them perform before. Chances are this is not really the developer who you think it is, right? So this is a different presentation layer. Let me see if I have a couple more. This is a presentation layer of what I was talking to you earlier, asking the question, do I have any instances exposed to the internet? What class of instance? So now we present to you the data in a network topology map. And what you see above here, which may be a little hard to read, is a query language, where you can pretty much ask any arbitrary question about networks, about users, about configurations, all through that. So again, the data is presented based on the kind of data, the use case it is as well. I don't know if that answers your question, if that's what you were hoping for. And all of this is available through API. Because a lot of times you're not going to be sitting waiting to sit and run queries. You just don't have time to do it, right? So automated alerting.
Wish you wouldn't use the word developer. Only
Okay.
because in my world, developers will never do this. They may develop in a development environment or a development instance, but they'll never be running in production. Our operations folks would be managing production.
And do you not yet have a DevOps team that's doing both combined in your environment?
We have a DevOps team that gets to the point where things are deployed into
Okay,
production.
fair enough.
But they don't manage production.
Fair enough. Yep.
So they work with getting everything up until it gets promoted
templates, got it.
promoted to production.
Got it.
But so there's a defined line between the two, and there's a reason for that.
Yeah.
Because up to that point, security may not actually be involved.
Yep. Fair enough.
And we really want security involved on production and we really want to limit and control who has access to that.
Yeah, and I think what we have built, if you think about the build, the deploy, and the run phases I mentioned, build will be completely developers. Deploy will be DevOps. Run will be a lot of where the security alerting that is more runtime related is occurring as well.
We actually do, or ideally, I'm not sure, I'm not going to say who does it, but ideally you should be doing security at all levels so that
Yes.
the developers work within the secure environment.
Yes.
So that they get the alerts that they know they need to fix
Yes.
right then.
Early feedback. Yeah.
Early feedback, and then when they do the build, deploy into testing, they're still in a secure environment.
Yeah.
So basically, I'm a big fan of measuring 12 inches to the foot
Yeah.
instead of 1.
Agreed. And I think that's our philosophy in building these capabilities is don't build it so far on one side and over-rotate it that give that early feedback in that entire process.
Part of that also is retraining your developers.
To be secure.
Well,
Because developers, a lot of times, they know what they're doing and they got the blinders on and they want to get systems up and running. And security becomes we'll just add that later or someone else will do it or whatever, and that's not a good thing.
And that's what I think the view you're seeing here is more of the security-centric view. Developers are not going to come and look for this stuff. Their feedback is given to them inside of Jenkins, inside of their build tools. And
they'll
so,
just fail.
sorry?
They'll just fail the scans or fail whatever, and that's actually usually not enough information to fix the problem.
Yeah, so we've worked really hard to make sure when anything that gets failed, there's complete feedback on what they need to do prescriptively to go fix it.
you
it's actually fascinating. I'd encourage you guys to try some of those, the DevOps-centric tools. They're available free. They're available at developers.paloaltonetworks.com/Prisma. So please try them. Please give us feedback. I think it'd be fascinating to see how we're trying to, again, address that audience, change the dynamic of, they don't understand this, so give them feedback that they can really act upon.
Does Prisma have the capability, so if I was a security person, we were doing encryption,
Yeah.
that when we detected that they, in their code, scripting or whatever, that they were doing encryption incorrectly, we just switch out with the right primitive, so that underneath just does the right thing for them?
Yeah, no, it doesn't get into the application code logic. So the way this is working is more on the infrastructure and PaaS layer today.
But to me, that would be the PaaS layer. It's like changing out what primitives are using to be the right
On the
ones.
API configuration, yes. So let me give you a couple examples where it would go autocorrect. Let's take three. Security group. User, you have said your policy states, thou shalt not open up security groups to the internet. Developer or a DevOps or whoever ends up pushing a new security group, either manually or through code, and that it has an incorrect configuration. The system can automatically go remove that offending ACL from that, so you don't have that problem. Let's take one for S3 buckets. somebody left an S3 bucket open to the internet. Common thing, we've all heard about the nightmares with that. You can make sure that it turns it off to private. So it is not accessible to the public. Sorry, go ahead. Yeah.
I was just going to make a comment on the whole developers don't think about security. That's complete BS right now in today's environments because developers keep getting blamed for all the holes and all the breaches and everything. Developers are the ones that they're looking more and more into how to actually be more secure, how to consume these APIs so they can try to develop proactive, not necessarily reactive systems that are trying to figure out, okay, I just got compromised. Now what do I do? It's more about trying to figure out the trending analysis to determine something is going on. I don't want to end up on Shodan and be listed as all these ports open. So how can I change my
Not that they're
index?
They don't care about security, but that a lot of times it's a retraining for them. Helping security needs to help them with the. You need to start from the beginning with a security conscious.
Yes, and I don't think that's retraining. I mean, I build applications and web applications all the time, and the first thing that comes to mind is, are my SQL statements protected? Are my admin pages protected? HTTPS, Let's Encrypt has done a huge push into getting
I've seen
SSL
developers who know that
certificates.
stuff.
I mean, that's the thing is it's not so much a retraining, it's just in the past, you were correct, is that it was get this crap out and get it out as fast as you can do it. Now it's more of don't put me on the front page of the newspaper. I want to make sure this is done correctly, and that's why I applaud all the APIs because they are certainly an exposure point into a lot of potential mining setups for when people are trying to figure out things. But at the same time, it's allowing developers to be more proactive as opposed to reactive and try to make it so that we don't necessarily have to worry about getting that notification that says we were just compromised.
And it's also a requirement, and going along with that, the security team needs to be working with the development team to ensure that happens in real time while they're developing so that they can give the advice they need to fix it. Because some of the times the stuff like crypto-related things, oh yeah, I just did a TLS cert. Well, we need to protect the private key and a bunch of other things and where you store it. They may not think about these other things because all they're thinking about, I got the right cert. It's like, no, you got more to do.
Well, that raises a key point that security is a collaborative effort. It's not a.
Absolutely. Has to be.
It has to be training on all sides of each other because we're all going to have our own perspectives on it.
Look, the developers are going to have to learn security, but the security teams here in the cloud case have to learn the cloud. Because even if we give you alerts, what are you going to do? You don't even know where to start.
Does it tie into your code pipeline? I mean, if you're doing for AWS, can you have it look at your cloud formation, say, hey, someone made a change, and can we run that process against it and say, hey, security group is open, why?
Yes. So those are free tools on developers.paloaltonetworks.com/Prisma.
Okay.
You can scan Terraform, you can scan CloudFormation, all of that.